Hi, my name is Kurt Kukine with Hammerspace, and I'll be talking to you about the Open Flash Platform Initiative. So what Molly and Floyd talked about, right, was really core product capabilities of Hammerspace and operating on tier 0, right, the performance of the product, the performance of the AI workloads really highlighted there. But beyond performance, right, we all know there's this really impending existential problem around data and data centers and all of that in terms of power, in terms of cooling, and in terms of the fact that we're just trying to cram so much data into what is a finite space, right? And so real estate is a challenge, and we're starting to generate more and more data out at the edge, right? All of our phones are getting more powerful. All of the devices that are out there, all of the sensors are getting more and more powerful, more and more granular. So all this additional information that we're trying to ingest. And a lot of the focus of AI so far has been compute-centric, right? We're focused on which flavor of GPUs is most recent and how powerful those are. But what of the data estate, the challenge that we've got with getting all of the data into the data center and then being able to store it there efficiently? And so with that, right, we see this need for really, really large capacity of storage that essentially disappears into the data center. And I'll tell you how we do that. So, there's a few components that make the Open Flash platform that we're proposing possible today, right? Well, we've seen developments in. So the large capacity flash, right? With the adoption of and wide availability of QLC, we've got flash that's really, really dense and can supply that cost-optimized tier in a flash platform. DPUs have essentially gotten powerful enough that they can serve as a replacement for those CPU-based storage servers out there, right? And when you look at storage servers out there in the environment today, right, that's how essentially every storage platform out there operates, right? You put in a storage server and put a bunch of disks behind it. Those storage servers are very expensive, both from a procurement standpoint, right? You've got CPUs, you've got memory, you've got all the infrastructure around it, and then also from an operating standpoint. You've got to power those things, you've got to cool those. So these DPUs becoming very powerful are allowing us to essentially replace all of that server infrastructure. And then we've already gone over, right, Floyd and Molly, a lot of the enhancements that have been done to the Linux kernel to supply data services.
So are you talking like of a JBoss that's actually a Linux server with DPU and lots of QLC flash? I'm trying to figure out
exactly
what the flash thing is.
Yep. So I'm going to jump ahead just because my friends have given me a limited amount of time here and go through some, jump over some of the laying the groundwork and really just jump into, okay, what is this thing, right? So number one, what is this thing? The first thing is this is an industry initiative. It's not a Hammerspace only thing, right? We want to make sure that people understand. We want to continue with this. We talked a lot about the standards-based approach. And so this is a standards-based approach. We've got other industry players. I'll go over who's already in the fold, and there's a lot of momentum and interest as well. But essentially, what we want to create is a platform that allows us, our goal is basically be able to deploy an exabyte in a rack. We wouldn't necessarily deploy it that way, right? You might just deploy some smaller amount within each server rack or something like that. But here's the basic proposal, right, is we design a sled that then fits into a tray that then can be deployed within a rack. So how does this change the game fundamentally? It's from a density and power standpoint, right? So this image here is essentially the entire server, right? This replaces an entire storage server. You've got a DPU, you've got your networking, and you got your storage. Really, really lightweight in terms of power and cooling requirements, a really lightweight server in there on top of the DPU. And then you've packaged your NVMe in there very, very tightly because you don't have the same cooling requirements that you have with the full server infrastructure. And so essentially this is the little one-use sled that fits into these larger trays, right? And you can deploy them, modularly, start with 2 and grow as needed, but this provides your capacity layer. Now, what we're about to show to the market within about a month or so is a really initial concept, right? Which is this using U.2 drives within this platform. We can get to a fairly reasonably dense position, but it's not getting us to our complete goal. What we'd like to do is actually extend the E.2 standard that would fully allow us to pack even more capacity into these sleds.
I was going to ask why you were using U2 drives, but
yeah,
okay.
It's what's available today, and allows us to really show a good proof of concept to the market so that we can get everyone interested in where we want to go.
Okay.
And so this is really what we see as the ultimate result of the Open Flash Platform Initiative. Right?
Why does
adoption of something?
Yeah, why does the power not go up? You quadrupled the density, and the power stayed the same.
Just the different form factors.
Yeah,
in terms of
essentially
different
different.
power.
Yeah, power distribution and form factor. So the idle requirement, right, of each drive is pretty nominal, and so you're not driving up, that maybe if you're hitting them really heavily, you might get an increase in power requirements, but generally, it's not going to be much there, right?
So what is Hammerspace's role? You're leading the consortium.
We're really advocating.
But who's
for
going to
this
actually
form
build this?
We have contract manufacturers that are engaged with us today.
So you will then sell them yourselves?
We will sell them ourselves, but we're also saying that this is not, we don't, again, want another proprietor. Other people have packaged Flash in interesting ways, right? Pure is out there doing it themselves. But we want something that is non-proprietary, that's widely available to the industry. We've also talked to, folks like the hyperscalers. We see this potentially as an OCP adopted. We haven't gone through all of that process that needs to be there, but we would eventually like to see it as part of the OCP initiatives as well. And
was the founder of Fusion.io. Our founder, David Flynn, was the founder of Fusion.io, so he does have a lot of experience in building this kind of technology. What we're bringing is the initial funding of the contract manufacturer to pull it all together. Of course, all the Linux contributions, so you can run Linux and take advantage of the DPU. And then we're pulling the group together, the DPU partners, the SSD partners. If you look at the website, you can see who they are right now. There's a bunch more jumping in. So we're kind of bringing folks together, but with the ultimate goal that most likely OCP will take it over. And then this will be a system which we're particularly optimized for because we're used to using Linux agents that are built into Linux. If another storage company wanted to use it, they'd still need to have their storage servers in front of it, so they don't get the same efficiency of power usage and density because they have to add the additional storage servers, which we don't. So that's the motivation behind it.
Okay.
And ultimately that these can run in hot data centers, low power environments, which is where we see AI infrastructure needing to go in the next year or two.
Does it have the high availability? I mean, dual server processing and stuff like that? I mean, dual ported SSDs, I mean, all that stuff, is that all part of this package?
So what we're seeing is building kind of redundancy in much more at the
Higher levels.
at the next level, yeah, at the software levels, and that way you keep these systems as simple and as cheap as possible. And in fact, right, if you get it to such a place, what's the reason why we need all of this, these replaceable components within a server, and you're constantly servicing your servers? Because they're very expensive, right? And essentially, if you get to this level of cost, you can even just fail in place, right? At the NAND level, right? Just leave it in there and run with just a little bit less NAND capacity within each unit. It's not going to be something you're going to want to be constantly servicing, and so that drives down overhead.
What advantage do you see of this over an EDSFF form factor for SSDs?
I think the biggest thing that we see is, again, just how tightly you can pack these things in.
Okay, but I mean that was the point of the EDSFF form factors, is that you could like, I think they can fit 16 of them into one chassis at this point.
So yeah, but now we're talking about, I mean, many factors larger than 16, right? This is a
capacity play, and this is all QLC, right? So it's read heavy.
So
Well, no, I'm sorry. You're saying 24 petabyte capacity assumes QLC.
it assumes QLC.
So you could have
Doesn't
different.
have to be,
yeah,
and interesting
okay.
enough, while we think QLC is the right form factor, or right for this form factor, right for capacity workloads, actually some of our first customers that are talking to us about it are looking at putting QLC.
Yeah. Okay. It's also usage. I mean, QLC is much more for read heavy.
Exactly.
Applications.
So when you're looking at these kinds of capacities, right, you're talking about probably archival,
Yeah.
but online archive, again,
Yeah.
right?
Yeah,
In the AI workloads, you're constantly
Streaming also. It's
going
not
back,
just
right?
yeah.
You're streaming things, so the performance out of the system too, right? While each individual of these sleds is fairly good, right? Performance, the aggregate performance that you're getting out of the system. And I'll do a pretty quick comparison here, right? So let me go back to, right? So here's what we think of a modern, actually using flash capacities that'll be available in early 2026, right? As the comparison here. We can take, a really nice all-flash scale-out NAS platform, right, and reduce that footprint from a full rack into essentially 2U of 1U trays, right? And so this is really an order of magnitude decrease in the amount of space and power that's required for this amount of capacity.
So, and the DPUs you're using are just industry standard GPUs, depending on your members in the
Exactly right. So again, right, we don't want to look at just one CPU. Yes, of course, for our first POC, we're working with a partner who's really eager to get this to market as well. But we've looked at other GPUs as well, and they've been just as functional and interesting. So again, we think this form factor is something we would like to see adopted much broader than just Hammerspace, right? And talking to some of the hyperscalers that are interested, right? That's where we can also continue to drive down costs by getting volume, right? We want to be able to get volume through this form factor as well to drive down the cost.
The comparison you have has got metadata servers and storage servers in this configuration versus just storage servers.
If we're being totally
Honest?
yes, we would require some Hammerspace servers within that rack, and we should put those in there.
2U.
And that's going to take up another 2U.
Can the Anvil be one of these units? I mean, is that
So the DPU that we are using today, it does look possible. We're doing some engineering to see if that would work, and that would be a panacea for us, for sure. Right now, we're probably taking a little bit too much resources up to be able to fit it in that, but I think ultimately that is a goal as well.
But Anvil wouldn't need that much capacity.
No, it wouldn't need that much capacity. That's correct. But if you can shrink it down to just be a component within that form factor, it makes sense. It's just something that we're not doing initially. That really there for the capacity.
So what all do you offer in the way of hardware?
Actually, Floyd, do you want to talk a little bit about kind of our hardware offering today? And again, right, this is an initiative. We're still in early stages, and we're getting more and more partners on board. We're expecting at the next OCP show to show our
Working prototype.
working prototype. And we actually plan to ship early systems to customers within this year. But I would say wider availability systems, right, for folks who are interested in this is in 2026.
And again, Hammerspace is still a software company, and our primary motion is software. But as Molly mentioned earlier, with the AI ready nodes and Hammerspace, what we call Hammerspace ready nodes, we're working with hardware partners. This would be part of that. So we will not have, maybe not initially, a hardware SKU, that is we're a manufacturer of, although we may have branded Hammerspace ready nodes, both for on the OFP side for a capacity layer, and on the compute side for Anvil and DSX. And to your question earlier, it wouldn't really be the Anvil that would be embedded in this. It would be a containerized DSX, right? So the DSX would, like today.
Yeah, I understand that. That would be the storage server side of things, but you still need to have Anvil in a Hammerspace solution at some point.
Sure. And by containerizing both the DSX and the Anvil, and I'm getting into roadmap that we're not really supposed to be talking about, but by containerizing these things, it just makes them much more easily deployable. Think especially in the cloud. As you have scale out Anvils containerized so that you can go as wide as you need and get that parallel I/O. So you're seeing a theme here. Build into a standard on the storage side, enhance it with our investment. We're funding the prototyping, the initial CMs, all of this, just like we have funded all of the work that we've pushed into the Linux community, so that standards on the storage side, standards on the client side, and then building that same architecture that Hammerspace is uniquely able to activate into Hammerspace to do it in a way that is non-proprietary.
Here are the early members, right, of the initiative. We are building our early prototype with the Excite DPU. It's a really interesting and really powerful DPU. So suggest looking into them, for more information around that, along with a number of the flash players, and we have many more coming on board here in the not distant future. So I think, really, to summarize, a lot of what we were talking about today is, one of the things that Hammerspace really wants to emphasize is that, we're following this open highways versus walled garden model, where, it doesn't make sense to us to say to the customers, hey, get rid of all of your data silos by moving all of your data into a data silo, right? What makes more sense is leave your data where it is today, but figure out how to manage it centrally. Make sure you can modernize your storage systems, right, without having to necessarily buy additional storage systems. You can utilize that flash that's available in tier 0. You can utilize your infrastructure that you have today. And when you need to expand, then we've got these optimized platforms for capacity, right? But you're not having to invest in a completely new infrastructure environment to take advantage of Hammerspace and to get the data acceleration that we provide, as well as the span of control over your data, where it lives, where it needs to get to, whether that's on-prem or in a multi-cloud environment. And that everything should be based on this standards-based approach, rather than having to put your stuff into a proprietary file system that then also introduces this need for these really, really power and cooling-hungry storage servers. And so we definitely think this is the right approach, right? The modern AI environment.